So this is the seventh video on friction. So in this video also I'll take up a numerical problem on kinetic friction. Okay. First I'll write down the question. A small block of mass m is placed over a rough horizontal surface at point 2 and is given an initial rightward speed of 20 meter per second with respect to ground. The friction coefficient between the block and the surface depends on distance x moved from O as mu equal to 0.4x. Take g equal to 10 meter per second square. Okay. Take g equal to 10 meter per second square. Alright. Now four things we have to evaluate. First is this. Find the speed v of the block. Find the speed v of the block as a function of distance x moved from O till it comes to rest. Second is find the distance x from O by the block as a function of time t till it comes to rest. Third is find the total distance L. Find the distance L moved by block till it finally comes to rest. Okay. I'll rub this now. And fourth is this. Find the time of journey of the block before it comes to rest. Find the time of journey of block before it comes to rest. Okay. These four things we have to evaluate. Alright. I wrap this. I draw the diagram of the situation. Okay. See, this is a rough horizontal surface. O is the point on the block of the surface. Here is a small block of mass m. It is given an initial rightward speed of u equal to 20 meter per second. This is the situation at time 0. After some time, the block comes here at time t. It has moved a distance of say x. Due to friction, its speed has decreased to v. Now we have to do in part A of the question, we have to find v in terms of x. In part A of the question, we have to find v in terms of x. So for that, what I'll do, I'll first draw the free body of the block with respect to ground at arbitrary instant t. Only real forces will act mg and n, and friction force will act leftward, opposite to direction of relative slip. Now friction force is equal to mu n because slipping is taking place between the block and the surface. Mu is given to be 0.4x. N is just equal to numerically equal to weight of the block, mg. Okay. G is given to be 10. So 0.4 into 10 becomes 4. So this becomes how much? G is 10. 10 into 0.4 becomes 4. So this becomes 4 mx. This is the magnitude of friction force acting on the block at time t and is directed in leftward direction. Okay, opposite to direction of relative slip. Fine. G is 10. 0.4 into 10 becomes 4 mx. Okay. Now apply Newton's second law to block with respect to ground in rightward direction. So what do I write? M dv by dt equal to net force on the block in this direction. That is just equal to minus 4 mx. M will go away. So we get dv by dt equal to minus 4x. Okay, fine. G is 10. 10 into 0.4 becomes 4 mx. Now V is what? V is just equal to dx by dt. Now dv by dt can be written as what? dv by dt by chain rule can be written as dv by dx into dx by dt. Now dx by dt is just equal to v. So dv by dt becomes v dv by dx. This is a substitute here. V dv by dx is equal to minus 4x. Now shift dx that side. Minus 4x into dx. Now I integrate this equation from both sides. Initially x is 0. Then corresponding value of v is u, 20 meter per second. Upper limit x becomes x. Corresponding v becomes v. Now I integrate this equation and inserting limits. V square by 2 minus u square by 2. Minus 4x dx becomes minus 2x square. Fine. This becomes how much? V square by 2 minus u square by 2 is equal to minus 2x square. Alright. So I will multiply this by 2. U is 20. So u square plus minus 4x square. V square is equal to u square minus 4x square. Alright. Now I rub this one. So now u is how much? U is given to be 20. 400 minus 4x square. So v becomes root under 400 minus 4x square is the answer to part A of the question. Okay. Now in part B of the question, we have been asked to find x as a function of time. See, one way of finding x as a function of time is we replace v by dx by dt. And then we integrate this equation with respect to x and t to get the answer. But there is another easier way out to find x as a function of time. We use this equation here. dv by dt is equal to minus 4x and v is equal to dx by dt. So here we get d by dt of dx by dt is minus 4x. Alright. Now rub that side. So this becomes d2x by dt2. Equal to minus 4x. Now I bring this left side. 0. So this is the second order linear differential equation with t as the independent variable and x as the dependent variable. It is of the form d2x by dt2 plus omega square x equal to 0, where omega square is 4 constant. Now I have been repeatedly telling that this type of differential equation solution should be remembered by heart, because in JEE Advanced these such types of questions are being asked in physics paper. You can go to 2023, 2024, you get questions based on this differential equation. So solution of this differential equation becomes x is equal to a1 cos omega t plus a2 sin omega t, where omega is equal to 4, omega square is 4, so omega is equal to 2. Now a1 and a2 are constants. To determine x as a function of time, we have to remove a1 and a2. So two constants are there, a1 and a2. We need two conditions. At time 0, the x coordinate of the block is 0. At t0, we put x equal to 0. 0 is equal to a1 cos 0 plus a2 sin 0. Sin 0 becomes 0. Cos 0 becomes 1. So a1 becomes 0. Okay. a1 becomes how much? 0. a1 is 0. Alright. Fine. Alright. a1 is how much? 0. I wrap this here. Okay. Now we also need to determine a2. Now it is given that at time 0, the velocity of the block is u, 20 meter per second. Now velocity at arbitrary time is nothing but dx by dt. Now a1 is 0, so this term goes away. Only a2 sin omega t remains. So this becomes a2 omega cos of omega t. This is v. At time 0, v is given to be how much? U, 20 meter per second. a2. Omega square is 4, so omega is equal to 2. So 2. Cos 0 becomes 1. a2 becomes 10. Okay. a2 has also been determined. Okay. So general solution becomes x equal to a1 cos omega t plus a2 sin omega t. a1 is 0. This term goes away. a2 is equal to 10. This becomes 10 sin 2t. This is the required answer. Alright, fine. So x equal to 10 sin 2t. This is x as a function of time. This answer also has been hopefully obtained. Okay. So x is how much? 10 sin 2t. That is the value of x. I hope it is clear. Fine. Alright. Now rub that side. Okay. The third part, it has been asked, what is the distance L moved by point before it comes to rest? So let L be the distance moved before it comes to rest. So when x is equal to L, v is equal to 0. Implies v is equal to 0. So here I put x equal to L and replace v by 0. 0 is equal to root under 400 minus 4l square. So 4l square minus 400 becomes 0. L square becomes 100. L becomes 10 meter. This is the answer to part C of the question. Okay, fine. Now lastly we have been asked, after what time the point comes to rest? Now when the point comes to rest, x is equal to 10 meter. So here instead of x I replace by 10. Because after covering 10 meter, the block comes to rest. So 10 equal to 10 sin 2t. Okay. So this 10 cancels out. Sin 2t becomes plus 1. So 2t becomes pi by 2. That is the smallest t when this equation is valid. After t equal to 0. So pi becomes pi by 4 second. Okay, fine. So t is equal to pi by 4 second is the required answer. Okay. So after this much time, the block finally comes to rest. So this question has been fully solved. All the parts of the question have been solved fully. Okay. So such question can be asked in JEE Advance in coming years. There is no doubt. There's a lot of chance that such questions can be asked. Okay. This was the 7th video. I'll take up the 8th video on this friction. That will also be based on the problem of kinetic friction. Okay. So this I close it here. In case you have any doubt, you put your doubt in the comment box. I'll clarify it. Okay. So I rub it now.